Hello, this is presentation 6 for Engineering 305. Alexis Davies and myself, Jessica Hausneck, will be presenting. So this is an outline of our presentation. First, we'll be just giving an overview of time series data analysis, forecasting. Then we'll use the data set workers to describe the methods to create a time series forecast. Then we'll describe how to analyze the model and discuss its accuracy. And then we'll describe how to predict age periods into the future. A time series data set consists of a set of n observations taken over a series of equally spaced time periods. A time series forecast is predicting a particular value, the dependent variable, against the independent variable time into the future. In addition, the platform in JUMP also allows us to analyze autocorrelations and partial autocorrelations of the series, which refer to how and to what degree each point in the series is correlated with earlier values in the series. And these are shown on the ACF and PACF. JUMP has two main time series forecasting modeling methods. One of these is the ARIMA, which explores and forecasts a single time series, which we will not be discussing in this video. We will be looking at JUMP's second primary time series modeling method called time series smoothing modeling, which generates forecasts when data contain trends or patterns. The time series smoothing models platform generates interpretable forecasts quickly and easily. Each smoothing model has an ARIMA model equivalent. There are several types of smoothing models, including Winner's method and SES. This is the form of the exponential smoothing model to the right. Depending on the specific model, sometimes the seasonal and trend components are 0. Each smoothing model defines a set of recursive smoothing equations that describes the evolution of these estimators. Smoothing models are also alike in that larger weights give more influence to recent data, while smaller weights give less influence to less recent. The best way to describe this model is to go right into JUMP and to demonstrate this model using the workers dataset, which can be found in the sample datasets, for example. To make our model, we go to Analyze, Modeling, and then click on Time Series. We put time on the x-axis if there's a time variable. Otherwise, the time intervals will be split evenly for the data points given for the y variable. And then we put electrical workers in the thousands in the y time series. And as you can see in the lower left corner, you can see that we are predicting 25 periods into the future. This top plot shows the actual data points against time. It looks like that there is seasonality with the curves that go up and down. So models with seasonality might make sense here. So we actually fit all of our models to our data, which you'll see on our PowerPoint. But for now in JUMP, we will compare Winner's method and seasonal exponential. So we go to Smoothing Model, Winner's method, Estimate, and then just do the same thing for the seasonal exponential model. So we can do a comparison and determine the accuracy of our models relative to one another. And we look at measures like the AIC and SBC to determine which is a better fit of the time series. If the AIC and SBC for a model are lower than for another, it is a better fit of the data set. As you can see, the Winner's method fit was better than the seasonal exponential fit since the AIC and SBC values for the Winner's method fit were lower. Also, MAPE and May were lower for this model, and the R-square value of this model is higher. And all these are also could be good indications that the model fit is better. So now we're going to go down to the forecast section. The one step ahead forecasts are shown overlaid on this plot with the input data points to the left of this blue vertical line. And then to the right of the blue vertical line, you can see future values forecasted by the model and the confidence intervals for the forecasts. We can see seasonality in our data, which is why it makes sense to use a model like Winner's and the seasonal exponential. It also makes sense in the context of the data set, since at different points of the year, a company might need less workers than other points. We can also analyze the residuals to determine if our model is a good fit. Each residual is equal to the difference between the actual value and the predicted value at that point based on our model. The data points should also be normally distributed about the 0 line, and the autocorrelation and partial autocorrelation of the residuals, which can be seen in the ACF and PACF respectively, should not have any significant components for lags greater than 0. Now we will explain how to predict out into the future age periods. So we set our time series in the launch window for predicting 25 periods in the future, and we will use the Winner's model since it was better. So we can save a table with our prediction formula. And if we go to the table and scroll down to the bottom, we can see our 25 values in the future. As you can see in the actual electrical workers column, there's nothing. And to the right of that, you can, in the predicted electrical workers, there are 25 forecasted values. The forecasts that appear above that are the one step ahead forecasts, which we saw earlier. As you can see, this is the comparison of the 6 models. You can see the other 4 ones and how they compare to the winners and seasonal exponential in this table. After it was determined that the winners model was the best fit, the predicted information can be exported into a table created by JUMP to show the predicted number of workers for roughly the next 2 years, or 25 periods. That concludes our presentation. Alexis demonstrated in SAS, JUMP, and the presentation while Jessica spoke. Thank you for watching.